Okay, so we are rationalizing denominators, which y'all have done before. So I'm going to remind you of ways that we've done it before. So we've done problems like this. And remember, we're not allowed to have square roots on the bottom. How do you get rid of a square root? You need it to be squared, but we can't just square it because it's not an equation. So we can multiply the bottom by itself, and that would make it squared, right? But what I do to the bottom, I have to do the exact same thing to the top. And now I have 2 root 3 over, well, isn't this the square root of 3 twice? So square root cancels the squared, and I get 2 root 3 over 3. So this we have already learned. Also, I want you to realize if you'd rather multiply that, you get square root of 9. And what's the square root of 9? 3. So is it different? Does it matter if you write it as squared or multiply it? No, you get the same answer. Okay, so knowing that, we know how to do that. Okay, we know that radicals are not allowed in the denominator. You also did problems like this. How would you get rid of that when you have plus or minus in the denominator?
Multiply by the opposite.
By the opposite, by the conjugate is the proper word. So we would do 4 plus the square root of 3. And what I do to the bottom, I have to do to the top because that's what keeps it equal, right? Because anything divided by itself, isn't that technically 1? So I'm practically multiplying this by 1. And when I multiply by 1, does that change anything mathematically? No, and that's why we're allowed to do that. So I'm not going to go all the way through that, but that's just a reminder of why we multiply by the conjugate and that you've already learned that. Yes? Okay, so that's a reminder from things we've already learned. So now let's learn the new stuff. So now we're dealing more with I. Okay, so this exact statement was on that other notes page. It says you should not have a radical or an I in the denominator. Yes? And we know that when it comes to I, we have 4 options. Right? Okay, so knowing that, we know that today we're trying to get rid of I. So we don't want this one or this one because those are still I. We want this one and this one. Now, I know that 0.0, I want y'all to realize, y'all, this is just a whole number. So if you're dividing in your calculator, 0.0 just means it's a whole number. Now, what do you notice about your exponents here? What do you notice about your exponents? 2, 4? They're even numbers. So even numbers, even exponents, cancel the I. So even exponents cancel the I. So that's what we want in our denominator, is if it's an odd exponent with our I, we want to make it even because then we can cancel it. Yes? Y'all, how do you make an odd number even? Don't you just give it one more? Yes, because every other number is even and every other number is odd. So knowing that, let's look at number 1. Okay, so we have 3 over 2 times 2i. Now, this is technically I to the first power. So my next even number would be 2. So I can multiply times I. Because do I care about the 2 in the denominator? No, I can have a number in the denominator all day, but I cannot have an I. So times I top and bottom. And I get 3i over 2i squared because I have I twice. Well, what does I squared equal? So now I have 3i over 2 times negative 1. And what is 2 times negative 1? So here's our answer. Now remember, our negatives can move. They're flexible. So we can also have negative 3i over 2, and that's the same thing. Yes? Okay. Any questions with that one? Okay, so look at number 2. We have 7 over I to the 7th power. So again, we have an odd exponent. We'll give it one more, and that will make it even. So times I. We get 7i over I to the what power? What would that give me? 8, because we add. So 7 plus 1 is 8. Now, we learned to divide by what yesterday? 4, because there's 4 options, right? So 8 divided by 4 is what? 2, which is a whole number. So what does the bottom equal? Now what's 7 divided by 1? 7. So this is just 7i. Y'all, you should start simplifying those fractions at this point. I do want you to simplify it without the fraction if possible. Any questions with that? Okay, I want y'all to try number 3 really fast while I take attendance. Okay, so what do you do first? Multiply top and bottom by what? I. And that gives us negative 4i over what? 10i to the 6th. So I know I have negative 4i on top and 10 times something on the bottom. So 6 divided by 4 is 0.5. So it's going to be negative 1. Well, what's 10 times negative 1? And so then we can simplify this. You can do it in the calculator. You can do it by hand. So negative 4 over negative 10. And we get 2 over 5. Don't forget to put your I back on top. Any questions with that one? Okay, so that's what you do when you have a monomial in the denominator. Yes, one term with no plus or minus. So back to when we have plus or minus, kind of like the reminder at the bottom, we have to do the conjugate. So if you look at example 4, what's the conjugate of my denominator? 2 plus I. So I'm going to multiply the bottom by 2 plus I, and what I do to the bottom I have to do to the top because that's what keeps it equal. Now, on the top, when you just have a monomial times your binomial, I would not multiply it through, because what if your denominator cancels it? Do you really want to multiply it in to have to take it right back out? No. So leave it out if it's a monomial. Now, on number 5, you'll multiply it because you have a binomial. Okay, it's different. And on the bottom, we're going to multiply. So what is 2 times 2? 2 times I. Negative I times 2. Negative 2i. And negative I times positive I. How many times do we multiply I? Twice. Yeah, so it's squared. Now, what happens to those middle two terms? Yeah, they cancel, which is what we wanted. Okay, and we've been multiplying these for like 2 days now, so hopefully we're good with this. So we have 4 minus, well, what does I squared equal? Negative 1, which is a broken plus sign, so what does this end up equaling? 5. For plus 1, remember the 2 negatives makes a positive and we get 5. So now I have 5 times 2 plus I over 5, and the 5's cancel. Now, why can this 5 cancel with the denominator? It's because it's multiplying. It's not adding or subtracting. Now, if this was 5 plus 2 plus I, it would not cancel, because remember, when you have that plus and minus, it makes things stuck like glue. Yes? Okay, so it's just 2 plus I. Any questions with that one? Okay, one more for the notes, and then I'm actually going to talk to you about something on the practice because it's not really covered on the notes, and then you'll practice and be done. Okay, so if you look at example 5, what are we going to multiply top and bottom by? No, that would be the exact same, and nothing cancels when they're exactly the same. 2 plus 6i. So 2 plus 6i. And what I do to the bottom, I do the exact same thing on the top. I've seen a lot of people today trying to do something different on the top. Don't do that, because then it's no longer equal, like over here where we talked about it being 1. It's not the same anymore, therefore you change the whole problem. Okay, so knowing that, we can distribute the whole thing this time because it's not a monomial times a binomial. So we're going to distribute, we can still do the bottom first. So what's 2 times 2?
4.
2 times positive 6i?
12.
Positive 12i. Negative 6i times 2? And negative 6i times positive 6i?
36i squared.
Negative 36i squared. Because a positive times a negative. If y'all need to think about it one piece at a time, don't hesitate to do that, because a lot of the things people are messing up on today is our negatives and our positives. Okay? So my middle two terms cancel, which is what I want to happen. And I have 4 minus 36 times what's I squared equal? Negative 1. Now, you can actually type this in your calculator just like this if you want to, but what's negative 36 times negative 1?
36
Positive 36, which gives me 40. So I know that my denominator is 40. Everybody okay with the denominator? Okay, so now let's multiply the top. And I have 3 times 2, which is 6. 3 times 6i, which is 18i, negative 2i times 2, which is, negative 4i, and negative 2i times 6i, which is negative 12i squared. Yes? Well, I know that these two are like terms. Nothing on the top should cancel, okay? Because that means you either multiplied by the wrong thing or this equaled 1 and you did way too much work. Yes? Okay, so knowing that, 18i minus 4i is just positive 14i. I'm going to go ahead and simplify those. I know that I should write my number without I first, so I left that spot open. Yes? And I have negative 12 times I squared, which is just negative 1. And what's negative 12 minus 1? Or times negative 1, sorry. Positive 12. And what's 6 plus 12? Now, is that my final answer? No, why not? What's wrong with it? Yeah, it can simplify. Now, here's the thing. When you simplify, please separate first. I've had a lot of people saying, oh, 18 over 40 simplifies to 9 over 20. Cool, 9 plus 14i over 20. That's not it. You have to simplify both terms on top. So 18 over 40 plus 14i over 40. And if you're not the best at simplifying, can you use your calculator? Yeah, now these are both even, so you can honestly just cut them in half. And if they cut a half again, cut them in half again if you're trying to do it by hand. What's half of 18? And what's half of 40? Now, this actually does not simplify further. Plus half of 14i is 7i over half of 40 is 20. Now, you can't type I in the calculator to simplify. Just don't forget to put it back if you did that in the calculator. Now, this is your answer. But I want you to realize because they both have 20 as your denominator, you could put it back like this. So just know that those are the same. You don't have to write it both ways, but I need you to understand that those are the exact same. Yes? Cool. Okay, practice is pretty short. So flip to the back, or the back, that's not from the back. Flip to the next page. Okay, number 10 is going to be bonus. Because it goes straight into like what you've already learned at this point. So I'd rather you focus on finishing the other ones, and y'all don't have 2 days for this practice, so I'd rather you finish the other ones first. Yes? Now, if you notice, number 7, 8, and 9 are a little different than what we were doing on the notes. But it has imaginary and radicals, so it's got a little bit of both. So why does this have an imaginary? How do I know? The negative inside my radical. So I have to make this positive and take out the I first thing because it's imaginary, so I have to make it imaginary. Label it as imaginary, I guess is a better word for that. Now, there's 2 different ways to do this one. You could just divide because 15 over 3 does simplify, but I want to show you both ways. So this one I'm going to do one way, and this one I'm going to do a different way because this one can't simplify. So we're going to get rid of the radical by multiplying by square root of 3. And we get the square root of 45 over I square root of 3 twice, right? Isn't that the square root of 3 twice? Square root cancels the squared, and I know I have 3i in the denominator. Is 45 a perfect square? No, so I have to break it down. Now I know that 3 times 15 gives me 45 because that's what I just multiplied. And then 3 and 5 is 15. So what gets to come out and what has to stay in? 3 root 5. Does that simplify? Womp womp. Yes, what cancels? 3. Now, am I done? No, what's wrong with it still? It has an I in the denominator. How do I get rid of that I in the denominator? Multiply top and bottom by I. Now, proper with a radical is we're going to rewrite this as I root 5 over, what's I times I? I squared. And what does I squared equal? Negative 1. Now, here's my question. Can negatives move up? Can I move that negative to the top and it's still negative? Yeah. And then anything divided by 1 is just itself, right? So negative I root 5. I don't need that 1 in the bottom anymore because I moved my negative up. You could also put a 1 here, and 1 divided by negative 1 is just negative 1. So it's the same concept. Any questions with that one? So it's kind of a twofer. And I'm going to help you with number 9. I'm not going to go all the way through it, but I'm going to go part of the way through it. Yes? So I know, again, I have to take out the i's first before I can combine anything. Well, what's I times I? I squared. I have the square root of 2 on the bottom. And what's 8 times 5? Because I can simplify those. 40. Good job. Yes, y'all are so smart. Thanks for nothing. Okay, I'm just kidding. So what does I squared equal? Negative 1. And now this is kind of what I was saying on number 7. Can I simplify 40 divided by 2? And remember, we can combine them under the house together when they have the same radical. And these are both square roots. What's 40 divided by 2?
20.
Now is this way easier? Yeah, there's no I in the denominator. There's no radical. There is no denominator anymore. And can I just break down the 20 and simplify? Yes. So that's what you're going to do from there to finish that one. So this is what you're working on. If you have questions, let me know.